Lesson: Identifying and analyzing processes for automation. Identifying and analyzing processes for automation is a critical step in the journey toward digital transformation. Robotic process automation offers a compelling avenue for organizations to streamline operations, reduce costs, and increase efficiency. However, the key to successful RPA implementation lies in discerning which processes are ripe for automation. This lesson explores actionable insights, practical tools, and frameworks that professionals can utilize to identify and analyze processes for effective automation with a focus on real-world applications and challenges. The initial step in identifying processes for automation involves understanding the characteristics of tasks most amenable to automation. Processes that are rule-based, repetitive, high-volume, and time-consuming are prime candidates. For instance, data entry tasks, invoice processing, and customer support inquiries often feature these traits, making them suitable for automation. Analyzing these processes requires a thorough understanding of the workflow to identify pain points and inefficiencies that automation could resolve. A practical tool to facilitate this analysis is process mining, a technique that uses data from IT systems to create a visual map of processes as they are executed. Process mining helps identify bottlenecks, deviations, and redundant steps, providing a factual basis for deciding which processes to automate. Companies like Siemens have successfully leveraged process mining to gain insights into their operations, leading to the automation of key processes and significant efficiency gains. Once potential processes for automation have been identified, the next step is to assess the potential impact and feasibility of automation. The Automation Potential Matrix, a framework that evaluates processes based on their complexity and potential benefits, can be instrumental in this stage. The matrix categorizes processes into 4 quadrants: low complexity and high benefit, high complexity and high benefit, low complexity and low benefit, and high complexity and low benefit. Processes in the low complexity and high benefit quadrant are often the best starting points for automation efforts, as they offer quick wins with minimal risk. A case study illustrating the use of the Automation Potential Matrix involves a financial services company seeking to automate its loan approval process. The company used the matrix to evaluate its processes and identified the initial credit check as a low-complexity, high-benefit task suitable for automation. By automating this step, the company reduced processing time by 30% and improved customer satisfaction, demonstrating the matrix's utility in guiding automation efforts. While identifying suitable processes for automation is crucial, analyzing the potential risks and challenges associated with automation is equally important. One common challenge is the resistance to change among employees who may fear job displacement. Addressing this challenge requires transparent communication and a commitment to upskilling and reskilling the workforce. Rather than replacing jobs, automation often reallocates human resources to more strategic tasks, enhancing job satisfaction and organizational value. Moreover, successful automation requires a robust governance framework to manage the lifecycle of automated processes. The robotic operating model, developed by Blue Prism, provides a comprehensive approach to governance by defining roles, responsibilities, and controls for managing RPA implementations. This framework ensures that automation aligns with organizational goals and compliance requirements, mitigating risks and maximizing benefits. To further illustrate the importance of governance, consider a multinational corporation that faced compliance issues due to a lack of standardized processes for managing bots. By adopting the ROM framework, the company established clear governance structures, reducing compliance risks and improving the overall effectiveness of its RPA initiatives. In addition to governance, integrating RPA with other emerging technologies can enhance automation outcomes. For example, combining RPA with artificial intelligence enables organizations to automate not only rule-based tasks, but also those requiring cognitive capabilities such as natural language processing and machine learning. This integration expands the scope of automation, allowing for more complex process automation and greater value creation. A practical example of such integration is found in the healthcare sector, where an AI-powered chatbot combined with RPA streamlines patient appointment scheduling. The chatbot handles initial patient interactions, while RPA processes the scheduling in the backend, resulting in a seamless experience for patients and reduced administrative burden for healthcare providers. Finally, continuous monitoring and optimization of automated processes are vital to sustaining the benefits of automation. The use of analytics tools provides insights into process performance, enabling organizations to identify areas for improvement and adapt to changing business needs. By regularly reviewing and refining automated processes, organizations can ensure they remain efficient and aligned with strategic objectives. In conclusion, identifying and analyzing processes for automation is a multifaceted endeavor that requires a strategic approach. By leveraging tools like process mining and frameworks such as the Automation Potential Matrix and the Robotic Operating Model, organizations can effectively assess and implement automation initiatives. Integrating RPA with AI, addressing change management challenges, and maintaining robust governance and optimization practices are essential to maximizing the benefits of automation. Through these strategies, professionals can enhance their proficiency in RPA, driving significant improvements in efficiency, cost savings, and value creation for their organizations.